Hi everyone, this is Mr.Xize from China Mobile. It's been really a long time since my last presentation in GTI. Today we are going to discuss one of the most important technology of proximity network, the passive IoT, which can be widely used in scenarios such as fully connected factory and other industries. Okay. First, let's talk about the requirements of industry digitalization. We cannot deny that eMBB and URLC are still the basic requirements of industries, especially like remote control and HD videos. However, the intelligent, automated, and visualized management of industrial elements are becoming more and more urgent. The connection and the management of large quantity of assets requires extreme low power consumption and low cost, just as Mr.Xize says, which will bring us over 100 billion level connections. Here we introduce passive IoT technology, the RFID. As a matter of fact, RFID has been developed for about 80 years, as we can see from the tab shaft. RFID has been widely used in the new retail, warehouse logistics, and other industries. But due to system interference, RFID's reading and writing distance is very close, which leads to high cost of deployment. Besides, it requires manual assistance, which cannot realize automated management. So academic circles are focusing on the evolution of RFID in the recent decade to meet the new requirements of wider coverage and stronger communication capability. According to the different requirements and the new trend of technology, we propose to design 3 stages of passive IoT. The stage 1 is just traditional technology, the point-to-point architecture. And the next stage is networking architecture, which introduces separation of transceiver to meet the requirement of large-scale management. We can just simply understand it as Wi-Fi mesh, although there are still many differences. The third stage is cellular architecture. We can see the whole new protocols, new architectures, new techs, and new future. Welcome to join us in standardization and other studies. And today's speech, let's talk more about the second stage. Passive IoT 2.0 introduces a separate transceiver architecture and supports multi-node joint networking to achieve long-distance seamless coverage. With the separation of signal sending and the receiving, it solves the interference problem, like self-interference and the mutual interference, which can realize data transmission over 100 meters. In addition to interference cancellation, we also introduce new algorithm like multi-node scheduling collaboration to realize real networking mode. Also, with multi-nodes and the multi-antennas and the reference tags, we can easily realize the antenna level positioning. Actually, we are working on the RSSI-based fingerprint algorithm to achieve a precise result. In this year, we have already developed passive IoT 2.0 system, including hardware products and the platforms. The products can achieve continuous coverage to identify tags in more than 100 meters. That's why we call it 100 in Chinese, which means it works good in 100 meters. Actually, in English, we call it ELARC. Furthermore, the receiver is called LAC-R, while the exciter is called LAC-Q. The original data is uploaded to the assets management platform. The platform provides visualization, business management, and the O&M functions. Here is the function and performance testing results. For device, it supports multi-R and multi-Q networking, and can realize medium and large area seamless coverage. Also, it can support automatic inventory, in and out storage and positioning, and remotely upgrade. In terms of the performance, it can realize more than 100 meters tag recognition, just like what I said. And the recognition accuracy reaches to 100% for 100 tag intensive scenarios. And the efficiency is more than 100 tags per second. For the platform, it supports cloud or local deployment and provides multiple interfaces to dock with, like MWS, ERP, and other OT systems. At the same time, through standardized functions and visual components, it can achieve rapid capacity building and customized development. In terms of performance, the processing efficiency of a single server is more than 10,000 tags per second. We have already implemented several pilot projects. The first showcase is in Guangzhou Mino. Mino is a service provider of automobile production line. The new passive IoT system has been deployed in Huadu factory of Mino to identify equipment information, report the location of the equipment, which realize automatic processing tracking service to improve the production efficiency. The next showcase is in Northern Information Port of China Mobile. There are tens of thousands of assets in the park, so it's very hard to count and manage all these stuffs. With the new passive IoT system, the inventory time is saved from months to just several days. Also, the asset loss will reduce by 50%. And I think it's the last page. Also, it is our vision. Nothing is inaccessible. Thank you, ladies and gentlemen. That's all.